Hello everybody, in this video we're going to talk about a theorem in geometry known as the Hinge Theorem. So it's kind of a long one here, so let's just read through it. It says if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first triangle is larger than the included angle of the second triangle, then the third side of the first triangle is longer than the third side of the second triangle, right? So a lot of firsts, seconds, and thirds in there, I know. So it kind of gets a little bit confusing, but look at our diagram right here. So here we can see that we have two triangles, we have two sides that are congruent, and so now we also have this included angle, right? So we can see from our two triangles here that the triangle on the left, the included angle is larger, it's 95 degrees, whereas the included angle on the right is 55 degrees. So essentially what this theorem is telling us is that this side here, this third side on my first triangle is going to be longer than the third side of the second triangle, okay? So a good illustration for this is to think about a gate, okay? So let's look at this diagram here on the left. Let's say we have a fence post at A, a fence post at B, and this yellow segment here is my gate. So let's imagine that I'm going to open the gate to right there, okay? So we could draw a triangle here. See if this will allow me to do that. All right, so there's our triangle right there, right? So now we could think side AB, this is the distance right here between the two fence posts. So that's not going to change, right? The fence posts aren't moving. And then this distance right here, that is the distance of the gate, right? Or the length of the gate. And obviously the gate is not getting bigger or smaller. So we know those two sides are staying the same. So let's call this point C. So we know that this third side over here is going to get bigger or smaller depending on how much I open the gate. Similarly, it affects this angle measure as well, right? The more I open the gate, let's say for example, the more we open the gate, notice how my side over here, I guess we can delete this yellow part now, but now my side C right here is getting longer, and notice this angle ABC is getting larger, right? So that's kind of how we illustrate this, right? So if I open my gate all the way, right? So now maybe we have a 90-degree angle and side AC is pretty large. But as we close the gate, notice our angle is getting smaller, eventually to an angle measure of 0, and we have shut the gate, okay? So that's kind of what this hinge theorem is telling us. And so we also have the converse to the hinge theorem, which basically states if we start with the angle measures, then we can tell which side is longer than the other, okay? So we'll look at a couple examples here, okay? So just one example, but two problems off of it. So we have this diagram here, and it says for number one, the measure of angle DBC, so DBC right here, is greater than the measure of angle DBA. So there's DBA. Which is longer, side DA, so side DA, or side DC, okay? Well, since my angle DBC, this angle right here is larger, then that means my side DC is going to be longer. So we're going to answer DC for that one, okay? Now let's clear up our markings here and look at number two. Number two says side DC is less than side DA. So this side is less than this side. So side DC is less than side DA, which is larger. Angle CBD, which is right here, angle CBD, or angle ABD, okay? Well, the longer side is going to be opposite of the larger angle. So since AD is the larger side or the longer side, then that's going to mean angle ABD will be larger, okay? And that is the hinge theorem.